Last time, we dug deep into the hollow earth, the vast caverns, the strange lights, the lost worlds beneath our feet. And honestly, that exploration raised the biggest, most uncomfortable question of all. What if the very shape of the earth itself isn't what we've been told? Tonight, we look across the surface we walk on every day at a theory so old, yet so persistent, that it challenges everything you know. Welcome to Conspiracy Anonymous. I'm your host, Anonymous. Tonight, we're forcing you to doubt the world under your own feet. If you enjoy this episode today, please leave a like and subscribe for more from the conspiracy world. Let's begin. Tonight, we're shifting our gaze. We're moving our perspective, not inward, but upward and outward. And I don't mean that we're looking into the vastness of outer space, at least not yet. Instead, we're looking across the very surface we walk on every single day. This entire episode is dedicated to exploring a theory so ancient, so foundational, that it actually predates the vast majority of modern scientific inquiry. Yet, it is also a theory so incredibly persistent that even now, in an age defined by high-powered satellites, crewed rockets, and international space stations, a dedicated and growing community of people genuinely still believe it. And this isn't just about believing it for a bit of intellectual fun or as a playful thought experiment. They believe it because, to them, there are genuinely significant and undeniable cracks in the official narrative. They see serious inconsistencies in the presented evidence, and they notice strange, small, but powerful details that, when you line them up, simply don't seem to add up to the perfect spherical picture we were given in school. This is the flat earth theory, and I want to be perfectly clear right from the start. I am not here to convince you of anything. I'm not here to preach this theory, nor am I here to conclusively debunk it, and I am certainly not here to laugh at it. My only purpose is to lay out the core arguments of the flat earth model, the same way we calmly and clearly approach the hollow earth theory, with a steady, objective perspective, and with just enough intellectual skepticism to keep our feet grounded in observable reality. Where the truth ultimately lands is a judgment I leave entirely up to you. So, please, just take a moment, sit back, relax, and take a deep breath. Because if there is one thing that the flat earth theory is uniquely good at, better than almost any other conspiracy, it is its ability to sow a deep, powerful seed of doubt about the very world that is under your own 2 feet. Let's begin this exploration. Most significant and compelling conspiracies, over time, eventually burn themselves out. They are either definitively debunked, replaced by fresher, more modern theories, or they are simply forgotten by the general public. But Flat Earth is a profound exception to this rule. It didn't die. It stuck around in the shadows of popular culture. Over the centuries, it quietly evolved. It adapted its arguments to new technologies and new scientific discoveries. And crucially, in the last decade, with the advent of accessible online platforms, it has absolutely exploded onto the internet in a massive, visible way. This resurgence isn't just happening in the form of angry, isolated comments or poorly produced memes. It is manifesting through fully produced feature-length documentaries, the formation of active and engaged online communities, the staging of large international conventions, and the funding of serious, organized experiments that genuinely attempt in their own unique methodology to prove that the world is not, in fact, a spinning sphere of rock floating aimlessly in space. So, the fundamental question we must ask is, why this particular theory? Why does the flat earth model not only survive but actively thrive, even with all the vast and immediate modern information available to us? Flat earthers offer a number of core reasons for their persistence, and they are worth listening to calmly. They argue that the existing, accepted evidence for a spherical Earth is simply not as airtight, as overwhelming, or as undeniable as the average person assumes it is. They claim that NASA's iconic images of the Earth are far less trustworthy than the space agency makes them out to be. They consistently point out that horizon lines, when viewed objectively, seem to behave in strange and inexplicable ways. They highlight that long-distance, intercontinental flight paths appear weirdly inefficient or nonsensical when mapped onto a globe. They view the continent of Antarctica with extreme suspicion, suggesting it holds a critical secret. And finally, they note that water, the oceans, the lakes, every body of liquid on the planet always, without exception, levels itself out to a flat surface. To those who believe, the world genuinely looks flat. It feels flat. And every bit of casual, direct observation seems to confirm that it behaves flat. They conclude that everything else, the entire globe model, is merely a deeply ingrained piece of cultural storytelling. Now, I am not suggesting that they are factually correct in their conclusions. I am also not claiming that they are demonstrably wrong, but it is essential, for the sake of intellectual honesty, to understand precisely why so many intelligent and motivated individuals believe in this model enough to stake their personal identity and reputation on it. Let's carefully break down their primary arguments, starting with direct observations. Flat earthers often begin their discourse with the most simple, direct, and universal observation that anyone can make, which they call the horizon problem. They simply state, when you look out at the horizon, whether you're on the sea or a high mountain, it is flat. And honestly, we have to acknowledge the visual reality of that statement. It does look that way. Whether you are standing on a remote beach, staring across a vast ocean, or perched on the observation deck of a towering skyscraper, the horizon line appears perfectly, resolutely straight. When you film it with a simple phone camera, or look at it with the unaided naked eye, the line remains straight across your field of view. Defenders of the globe model correctly explain that this is entirely expected behavior. The Earth is so astronomically huge that the curvature is simply not visible at a normal or even slightly elevated human scale. Flat earthers, however, respond by calling the phenomenon suspicious, pointing out a key detail. No matter how high you ascend, whether you are climbing a tall mountain, flying in a commercial airliner, or deploying a high-altitude weather balloon, the horizon always seems to rise to meet the precise level of the observer's eye. On a vast, smooth sphere, they counter-argue, the horizon should consistently appear to drop beneath you as you gain altitude, eventually forcing you to tilt your camera or head downward to see it. And it is small, seemingly insignificant details like this, anomalies in direct observation, that cause people to pause and critically reconsider the accepted model. Again, my goal here is not to tell you which interpretation is scientifically correct. My goal is to show you why this debate, fueled by these subtle observations, resolutely refuses to be settled. One of the most powerful and persistent arguments centers entirely around the nature and behavior of water, the single most abundant substance on our planet's surface. Flat earthers make a seemingly simple but powerful claim. Water always, without fail, finds and maintains a level surface. Water sits perfectly flat in every lake, pond, and container. Water, by its very nature, doesn't naturally curve, bend, or stick to the underside of objects. They then pose the logical follow-up question: how can the vast oceans of the world curve and stick perfectly around the exterior of a massive spinning sphere without the need for an external container? Scientists immediately reply that the force responsible is universal gravitation. Flat earthers then counter by demanding a physical demonstration. Show us measurable, verifiable curvature in a large, contained body of water like a vast lake or a calm stretch of canal. This has resulted in a persistent, decades-long tug of war between the two sides, where neither is fully convinced by the other's evidence. This is the point where the flat Earth theory often moves beyond simple observation and into more specific, interesting challenges to the globe model, which they call the long-distance visibility problem. Flat Earth documentaries frequently present compelling cases where distant objects such as mountains, skyscrapers, or even entire city skylines can allegedly be seen or photographed at distances far greater than the mathematical curvature of a spherical Earth should permit. Examples often cited include cities that should be entirely hidden below the curve of the Earth's bulge, landmarks that are visible from distances deemed physically impossible on a globe, laser light experiments conducted across vast, still lakes, and boats or ships that appear to be fully in view on the horizon, rather than having their hull hidden below the curvature, which is what the globe model predicts. Globe defenders have a standard, scientifically sound explanation for nearly every one of these sightings: atmospheric refraction. This is the phenomenon where light is bent or distorted as it passes through layers of air with different temperatures and densities, effectively creating a kind of atmospheric lens that allows people to see objects that are technically below the horizon. Flat earthers dismiss this explanation, claiming that refraction is simply a convenient, catch-all excuse used to account for every single inconsistency in the globe model. Both sides are able to produce evidence, yet neither side is persuaded by the other's interpretation of that same evidence. This argument is one of the more easily verifiable in the Flat Earth catalog, and it proves to be a fun mental exercise when looking at airplane flight paths. Flat Earth proponents often ask people to look closely at the published airline routes, especially those connecting locations in the Southern Hemisphere, such as flights from Australia to South America, South Africa to Australia, or Chile to New Zealand. On a standard globe, the shortest, most efficient path between these points should be a relatively straight line, known as a Great Circle route. However, many real-world flight paths between these points often involve strange, seemingly inefficient layovers in the Northern Hemisphere, or they trace weirdly curving paths that, when plotted onto the Flat Earth's azimuthal equidistant map, suddenly appear much more straight and logical. Does this single point prove the Earth is flat? Not necessarily. There are many real-world logistical reasons for commercial flight paths, such as economic routing, prevailing wind patterns, refueling, and avoiding specific airspaces that are unrelated to the planet's shape. But this remains one of those specific, confusing data points that Flat Earth proponents love to point to as a potential anomaly. For Flat Earthers, the National Aeronautics and Space Administration, or NASA, is positioned right at the heart of the entire conversation. This is not primarily about the agency's rockets or its immense funding, but fundamentally about trust. Flat Earthers meticulously point out several known facts about the space agency. NASA has openly admitted that many of the iconic, full Earth photos are in fact computer-generated composites, stitched together from multiple images taken over time, making them technically not a single, continuous photograph. Believers claim that certain photos and videos, when examined closely, appear to show repeated or tiled cloud patterns. They often highlight specific spacewalk videos that contain odd reflections, visual glitches, what appear to be air bubbles. And finally, there is the undeniable issue of the agency's open use of computer-generated imagery, CGI, for many educational or illustrative images of the Earth and space. For people who are already fundamentally suspicious of official government narratives and institutions, these verified facts that images are composites, that CGI is used, that glitches occur are enough to create significant and persistent doubt about the entire space program. Is this, in itself, concrete proof that the Earth is flat? Not at all. But is it enough to successfully fuel and sustain an entire global movement of passionate individuals? Absolutely. It provides the psychological foundation for the entire belief structure. If the Earth is demonstrably not a globe, the next logical question becomes, what shape is it, and how is it organized? Most of modern flat earthers agree upon a specific model known as the AE map, which stands for the azimuthal equidistant projection. The model is laid out like this. The Earth is a massive, circular disk. The North Pole is situated exactly at the geometric center of this disk. The continents spread outward from this center, like spokes on a wheel. And most distinctively, the continent we know as Antarctica does not exist as a continent in the south, but instead forms a gigantic, continuous, impenetrable wall of ice that completely encircles the entire disk of the Earth, defining its outer boundary. Is this map geometrically perfect? Not even close. It has numerous, well-documented problems, particularly when it comes to accurately depicting long-distance measurements, scaling, and the distortion of the continents, especially in the south. However, flat earthers quickly counter-argue that the globe model faces the exact same issues. Every single two-dimensional map, from the Mercator to the Peters projection, distorts something when projecting a three-dimensional sphere onto a flat plane. The question then becomes, which fundamental distortion represents the hidden truth? The ice wall is undoubtedly the most iconic and essential element of the flat Earth theory. It is not just visually dramatic, it raises a much larger, politically charged question. If Antarctica is truly the outer boundary of all known life, why are we, the general public, not allowed to freely and openly explore its entire circumference? This specific point about the ice wall might be the single biggest, most enduring pillar supporting public interest and conspiracy-minded speculation in the flat Earth model. Antarctica is not like other continents. It is heavily and uniquely restricted under the Antarctic Treaty system, an international agreement signed by dozens of nations. Under the treaty, you cannot mine there, you cannot build cities or military bases there, and you cannot explore or visit freely without serious permission and supervision. To flat earthers, this extreme level of global control is immediately and inherently suspicious. They ask, why is this one massive, supposedly empty continent the most politically protected and regulated landmass on the entire planet? Official supporters of the treaty state that the restrictions are absolutely necessary for the critical purpose of environmental preservation, scientific cooperation, and the prevention of resource exploitation. Flat earthers, however, push back saying, that explanation sounds reasonable and appealing, but the reality of the restrictions is still fundamentally weird. They believe that the truth is far simpler. Antarctica is not a landmass situated at the bottom of a globe. It is the massive, encircling boundary wall of our world. The treaty's true, unspoken purpose is to prevent any average citizen from successfully navigating the wall and discovering what lies at the actual edge of the world. Whether this belief is factually accurate or not is a matter for endless debate. But the fact that the international restrictions on the continent do exist is undeniable, and that political reality alone is more than enough to continually feed the engine of the flat Earth theory. If the Earth is conclusively proven not to be a sphere, then the implications for our understanding of the universe of space itself become profoundly existential. Flat Earthers tend to fall into several distinct philosophical camps when addressing space. Some accept the existence of planets, stars, and galaxies, but argue the physical laws apply differently to our flat domain. Others believe space travel is real, but that the universe and its distances are completely different from the official NASA model. A third group claims the sky is something else entirely. Perhaps a contained firmament, a dome, or just layers of atmosphere, and that true space travel as depicted is impossible or entirely fabricated. If one accepts the premise that the Earth is flat, a number of scientific cornerstones must be completely redefined or discarded. The established principles of gravity must either work in a totally new way, or they must not exist at all in the form we currently understand. The sun and the moon must be significantly smaller and much, much closer to the Earth than mainstream science claims. The behavior of the distant stars and the entire concept of an infinite universe must be fundamentally different, and space travel, as we currently believe it, might be nothing more than a carefully and globally maintained illusion. Some proponents accept that rockets and satellites physically exist and work. They just don't accept that they travel nearly as far, or into the environment, as we are told. Others claim that space itself is simply a powerful, all-encompassing narrative, a grand story used to explain phenomena that the average person is fundamentally unable to directly verify for themselves. And this is a powerful point. The average, non-scientist citizen cannot personally verify the claims of space agencies. We must rely entirely on the statements and photographic evidence provided by these large, often government-affiliated agencies and corporations. This complete dependence, this need for unwavering faith and authority, creates a vast, open room for doubt and suspicion, even if that doubt is ultimately misplaced or unwarranted. Flat Earth is not merely a debate about geometry, trigonometry, or maps. At its core, it is a profound psychological phenomenon and a testament to the modern crisis of trust. People gravitate strongly toward the flat Earth worldview for a complex array of sociological and mental reasons. They possess a deep, powerful feeling of being consistently lied to by large, opaque institutions. They naturally spot and resonate with inconsistencies found within complex official explanations. They seek out alternative viewpoints that give them intellectual ownership of their reality. They desperately want a model of the world that perfectly and directly matches what they can observe with their own eyes every single day. They possess a powerful, inherent, and understandable distrust of centralized authority figures. And honestly, at a purely intellectual level, the theory is incredibly fascinating and complex to explore. Flat Earth is ultimately less about the exact physical shape of the planet and much more about the perceived shape of trust in society. It transforms what appears to be a dry, academic science debate into a passionate, engaging worldview debate. In a modern world that is saturated with contradictory information, rife with perceived government secrecy, and plagued by frequently shifting official narratives, it is perfectly logical and understandable why some segments of the population would ultimately find themselves drawn to this particular worldview. It's crucial to understand that they do this not because they are unintelligent or gullible, but often precisely because they are highly skeptical, highly motivated, and actively looking for a coherent explanation that makes sense to them personally. When you successfully strip away the societal stigma and the ridicule that so often surrounds the theory, Flat Earth becomes a very profound and very human question. How well do we really know the world we live in, and who is truly in charge of defining its reality? Flat Earth communities have dedicated significant time, effort, and money to running countless experiments, all in an attempt to provide physical, demonstrable proof of their model. Some of these experiments are relatively basic and easily accessible, such as laser light tests across miles of still water, the use of sensitive gyroscopes to detect motion, extreme long-distance photography using powerful telephoto lenses, and horizon-level tests conducted at various altitudes. Others are significantly more elaborate and technologically ambitious, including high-altitude balloon launches with cameras, infrared and thermal footage analysis of the atmosphere, the use of LiDAR scans over long distances, and complex analysis of horizon lines and light behavior, sometimes referred to as black swan events. The results of these experiments tend to land in a gray area. Some of them, when objectively analyzed, inadvertently end up providing clear evidence that supports the globe model. Others successfully raise legitimate, puzzling questions about atmospheric effects and light behavior, and the vast majority of them fall into a murky middle ground where the final interpretation of the data and the acceptance of the margin of error is what ultimately decides the perceived outcome. One highly publicized experiment, for example, involved a sensitive gyroscope that unexpectedly detected a consistent rotational drift, a result that should directly support the idea of a spinning Earth. Flat Earthers, however, were quick to reinterpret the reading, claiming it proved something entirely different. Another major test involved a laser shown across a vast lake, yielding inconsistent measurements that were easily attributed to known effects like atmospheric refraction, but the community again chose a flat interpretation. The key takeaway is that not a single one of these experiments, no matter how clever or high-tech, has ever conclusively ended the debate. Instead, they have only successfully added more specific, technical data for both sides to argue over, serving only as additional fuel for the underlying curiosity. A significant portion of the Flat Earth community holds the belief that the theory is not merely a scientific error but an intentional, active component of a much larger, institutional deception. This idea is often secular and grounded in political and institutional skepticism, not necessarily spirituality. The underlying premise is that government agencies are habitually deceptive and possess a massive incentive to lie. Space agencies, they believe, actively exaggerate or completely fabricate much of their data and achievements. Scientific authorities are accused of gatekeeping crucial information, creating a closed-loop system of knowledge. The public education system, they argue, acts to reinforce the official, mainstream model without ever presenting alternatives. Ultimately, public knowledge is not a process of open discovery, but a carefully curated and controlled version of reality. Again, I am not endorsing this as fact, but this is the explicit, foundational reasoning used for the theory's longevity within the community. The debate shifts from one of simple geometry to a debate about the control and weaponization of information. This is the inevitable question that virtually every skeptic and outside observer asks, and it is the most difficult challenge for the Flat Earth model to successfully answer. If the Earth were demonstrably flat, what massive, compelling reason would there be for a global, coordinated, multi-century deception to hide it? Flat Earthers offer a number of compelling psychological and political possibilities in response. The immense funding, power, and political prestige tied up in the continued existence of global space and satellite programs, the desire to prevent the general population from ever truly knowing the complete, ultimate, or true structure of the world, the fundamental need to control the historical and future narratives of humanity, the simple maintenance of authority and global dominance by a select few, or, in a less sinister view, simply inheriting a massive lie that began centuries ago and is now impossible to retract. But the most common and compelling explanation, even from the most secular and non-spiritual believers, is this core psychological insight. Once a global system, political, financial, and scientific has fully committed to a single, foundational model, attempting to change it or admit the error would cause unimaginable chaos and the immediate collapse of that system. Whether you find that explanation true or not, it stands as a highly compelling psychological argument. People, and by extension governments and institutions, naturally prefer stability, comfort, and predictability, even if that stability is ultimately built upon what they perceive to be outdated or flawed assumptions. If we take a massive intellectual leap and assume the Earth actually was a flat disk, the implications for human knowledge and global society would be almost incomprehensibly massive. Every single one of our modern physics textbooks would be fundamentally incorrect. Our established understanding of the sky, stars, and time would be completely wrong. Global space programs would immediately collapse in a storm of doubt and scandal. The entire communications infrastructure built on satellites would require an entirely new, non-orbital explanation. Global governments and the entire scientific establishment would face immediate and profound global distrust and an unprecedented crisis of authority. This is why the Flat Earth debate, even if the premise is scientifically unlikely, matters so deeply. It matters not because the Earth is necessarily flat, but because the mere possibility of it being flat acts as a profound stress test for the foundations of what we, as a species, automatically accept as undeniable truth. Now, for a moment, let me share where I, the narrator, stand on this massive, polarizing topic. Like you, the listener, I am not fully convinced by the Flat Earth model's specific claims and counter-evidence, but I am also not willing to casually dismiss it outright, either. I clearly see the thoughtful questions that are being asked. I acknowledge the historical oddities and the specific details that seem to consistently fail to line up perfectly. My position is one of skepticism combined with absolute openness. I aim to remain intellectually grounded in what is verifiable, but relentlessly curious about what is not. I refuse to swallow the entire theory whole, but I also refuse to carelessly brush it off as simple nonsense or the ramblings of the easily fooled. Because the very moment you allow yourself to automatically and completely dismiss a major idea, no matter how outlandish it may seem, is the moment you effectively stop the vital process of learning and challenging your own assumptions. And the Flat Earth theory, whether its conclusions are true or false, undeniably forces you to think bigger. It forces you to look at the world around you with a fresh, critically discerning eye. It forces you to ask profound, uncomfortable questions that the vast majority of people never stop to consider. That intellectual and philosophical challenge, that simple act of questioning the foundation, is a process that is worth exploring for its own sake. For the sake of complete fairness and to ensure that this exploration remains as balanced and objective as possible, we must acknowledge the considerable, undeniable weaknesses in the Flat Earth model. The current Flat Earth model significantly struggles to convincingly account for a number of globally observed phenomena. Stellar parallax, the apparent shift in a star's position as the Earth moves, orbital mechanics, the established, predictable movements of every other body in the solar system, the reliable functionality of satellite communication and GPS, the existence of seasons, equinoxes, and time zones, where it is night on one side of the world and day on the other, the Coriolis effect, the force that influences weather patterns and wind direction, the fact that stars rotate in the opposite direction for viewers in the Southern Hemisphere, and finally, the massive logistical challenge of maintaining a perfect, absolute global conspiracy involving thousands of people for hundreds of years without a single credible leak. Globe defenders correctly point to these issues as undeniable proof that the Flat Earth model is simply not scientifically viable or physically possible. Flat Earthers typically counter with alternative explanations, but they often require a complete, total reworking of the entire known laws of physics and atmospheric science. This is the ultimate dividing line between simple curiosity and genuine belief. You can, with enough effort, find anomalies and inconsistencies in almost anything, but building a complete, cohesive, and fully working scientific model, one that accurately predicts and explains everything that is the truly hard part. Still, the lack of a perfect, all-explaining flat model has not, in any way, slowed the movement down. Sometimes, the power of a strong, persistent question is more than enough to sustain a conspiracy theory. This is inevitably the most speculative, and arguably the most fun, part of the entire Flat Earth discussion. If the Earth is indeed a flat disk, fully encircled by the impenetrable ice wall of Antarctica, then the critical question remains, what lies beyond that wall? Flat Earth speculation covers a wide and fascinating range of possibilities. The boundary gives way to an infinite, flat plane of existence. There is a vast, unmapped, unknown landmass of massive scale beyond the ice. There are entirely unknown territories, resources, or possibly even other civilizations. The entire system is contained within a solid, physical dome or firmament. Or it is just simply a literal, endless field of frozen ice. We have kept this exploration entirely secular, so we won't dive into the more heavy, metaphysical, and religious aspects that often accompany the firmament idea. But it is clear that flat Earth proponents love to intensely speculate about the uncharted lands beyond the Great Ice Wall. They dream of unknown continents, entirely new resources, ecosystems we have never imagined, and potentially even other human groups or civilizations that have been kept hidden from the central population. Is any of that realistic? Maybe, maybe not. But this particular line of thought taps into one of the most primal and enduring human desires, the idea that the map is not, in fact, complete. And that feeling, that sense of a hidden frontier, is more than enough to spark and fuel the deepest human imaginations. It is a well-observed fact that the flat Earth topic often makes people angry, not just annoyed or casually dismissive, but genuinely, passionately angry. This intense reaction occurs because the theory directly and fundamentally challenges the bedrock of global society. It challenges the concept of authority. It challenges the infallibility of science. It challenges the integrity of education. It challenges the core stability of every major institution. And it profoundly challenges the very fundamental concept of trust in the media and government. Flat Earth is a theory that asks you to question something so absolutely fundamental to your entire worldview that if you allow yourself to accept even a tiny, minuscule 1% chance that it might be true, the entire, comfortable structure of your reality begins to violently shake. That single psychological trigger is what makes the idea so powerful and so enduring, and in a way, it is what makes the idea subtly dangerous. Not dangerous because the Earth is flat, but dangerous because the idea itself forces you to confront the shocking reality of just how much of your current reality is inherited knowledge, rather than personally observed and verifiable fact. And now, we arrive at the natural conclusion of this intellectual journey. We have calmly and thoroughly covered the anomalies in the horizon, the puzzling behavior of water, the mystery of long-distance visibility, the strange puzzle of commercial flight paths, the questions surrounding NASA's evidence, the political restrictions of Antarctica, the psychological draw to the theory, the map, the experiments, and the government angle, the massive implications of its truth, and finally, the model's significant weaknesses. So, here is the real, ultimate question that this entire exploration leads to. What do you think? Is the Earth a globe? Probably. Maybe. But maybe not with the absolute certainty you once had. Is the flat Earth theory itself a truly convincing scientific model? That answer depends entirely on your own personal, carefully defined threshold for doubt and skepticism. But one thing remains absolutely certain, and this is the true power of the idea. Once you have allowed yourself to truly question the fundamental shape of the world you live on, you will never, ever look at the horizon, the sky, or the news the same way again. And that, in the end, is exactly what these major, global, pervasive theories are truly meant to do. Not necessarily to convert you into a believer, but to successfully crack open the fundamental, mind-bending possibility that the reality we inhabit is infinitely stranger, more mysterious, and more profoundly interesting than we have been given permission to believe. Thank you for listening to Conspiracy Anonymous. If you enjoyed this mind-bending episode and want to hear more explorations from the fringes of truth, please take a moment to leave a like and subscribe to my channel. Let me know what you think of the flat Earth arguments in the comments below, and tell me what conspiracy or mystery you would like us to dig into for the next video. Until then, stay curious, stay skeptical, and never stop questioning the map.